Hello, smart mathematicians. Let's do question 11b. We've done question 11a and we managed to find the equation of the circle with center P. Now let's do 11b. So in the diagram alongside, circles with centers M and P touch each other externally at N. What is the meaning of that? When you're saying they're touching externally, it means they're touching at each other at what? At one point. Okay, like one point at N here. Right. M is the center of the bigger circle. M, the center of the bigger circle, lies on the y-axis. Then P, the center of the smaller circle, lies on the x-axis. And then the equation of the straight line MNP is 3y plus 4x is equal to 12. Mn is 3 units. Determine the y-intercept of the tangent common to the circles at N. So we want the y-intercept of the tangent. Meaning what? Meaning that we have to find the equation of the tangent that is common to the two circles. Okay, so what do we know about the tangent? The tangent is perpendicular to the radius or perpendicular to the diameter. So it means the tangent will be something like this. Let's just have a picture of the tangent. This will be the tangent, isn't it? You see that? Which is perpendicular to the radius here. Which is perpendicular to the radius. You see that? And then remember we have the equation of what? Of MNP. We have the equation of MNP. So from the equation of MNP, we can find its gradient. We can find the gradient of MNP, and then remember the gradient of what? Of perpendicular lines. Right, the product of the gradients of perpendicular lines will give you -1. Or we can say that the gradient of the tangent is what? The negative reciprocal of MNP. The gradient of the tangent is the negative reciprocal of MNP. So we're going to find the gradient of MNP, and then after that we'll find the gradient of the tangent, because it is the negative reciprocal of MNP. And then with the gradient of the tangent and the coordinates of N, we are going to find the equation of the tangent. And then from the equation of the tangent, we are going to find the y-intercept. Now, how do we find the coordinates of N? Right, we have the equation of the circle. We have the equation of the line MNP. They intersect at N here. So it means here what we can do, we can solve these two equations simultaneously. And then once we solve them simultaneously, we're going to find the coordinates of N. You see that? Okay, so this is the equation of the circle with center P, and then we have the equation of the line MNP. Let's solve these two simultaneously, and then after that we're going to find the coordinates of N, and then we're going to find the gradient of MNP. From the gradient of MNP, we're going to find the gradient of the tangent, and then with the gradient of the tangent and the coordinates of N, we're going to find the equation of the tangent. Okay, you see that? Now, if you have a picture of what you're supposed to do here, you can pause the video and try it on your own before you move on. You just pause the video, try the steps that I've given you, and then you move on. By the way, I'm going to show you two methods of solving this problem, okay? So after this one, I'm going to show the other one where you're going to use similarity. Okay, right, let's just do the solving of these equations simultaneously. So we have equation 1 here, right? And then we have this equation 2, right? From equation 2, let's create equation 3. Okay, let's create equation 3. So I'm saying here 3y is equal to 12 minus 4x. Then let's make y the subject here. Let's make y the subject. Y is equal to 4. I'm dividing everything by 3 minus 4 over 3x. You see that? Let's call it equation 3. Now we can substitute our equation 3 into equation 1. Where there's y, we put Where there's y, we put what? We put 4 minus 4 over 3x. Right, these simplification of binomials, square binomials, which makes life very, very easy. You see that? So let's say you are, I'm trying to get space here. Right, let's say you are expanding a minus b squared. Okay, there's no need to do the FOIL method here. You just know that you square this a, becomes a squared, and then you say 2 times a times b. You take this sign is what? Negative. Then 2 times a times b, which is 2ab. You see that? You multiply this and 2. And then the last one, you square the last one, and then become plus b squared. You see that? You have done your expansion. So now that's what we're going to use here. You see that? Now let's substitute, and then we have x minus 3 squared plus, let's put this in the bracket, 4 minus 4 over 3 x, you see that, squared. We have replaced y with what? With that expression there, is equal to 4. Let me write this 2 squared as 4. Then now we need to expand. So we're going to use our method here. So it's going to be x squared here. We square that, and then the sign is negative, and then 2 times x times 3, which is 6x. And then we square the last term. It's going to be plus 9. You see that? Okay. Then we come here, same thing, plus 4 squared is 16. Then 2 times, the sign is negative here, 2 times 4 over 3x. Take note there, is 2 times 4 over 3x, not just 4 over 3. So it's going to be what? It's going to be 4 times 4 is 16 times 2, 32. So it's 32x over 3. Okay, and then we square the last one. It's going to be plus. Then take note there's x there, so it's going to be 16 x squared over 9 is equal to 4. Okay, we don't make mistakes here. Okay, we collect the like terms, make sure that we don't make mistakes. Okay, but you can skip this step if you think you can do without it. Then x squared plus 16 x squared over 9 minus 6x. Okay, we've collected this one and this one. Now we're doing negative 6x minus 32 x over 3. We've done these ones. We go to the constants, then plus 9 plus 16, and then this one minus 4, since it comes to the left, is equal to 0. You see that? Okay, right. And then what is 1 plus 16 over 9? That is 25 over 9. So it's 25 x squared over 9. And then you can use your calculator here. Minus 6 minus 32 over 3. You get what? You must get 50 x over 3. And then 9 plus 16 is 25. 25 minus 4 is 21. So plus 21 is equal to 0. You see that? Then you can multiply everything by the LCD. The lowest common multiple, yes, LCD. So you multiply by 9. Multiply everything by 9. So it becomes 25 x squared minus 150x plus 189 is equal to 0. That is our equation in standard form. Then we solve. So maybe factorization is going to be a problem here. So we can use the quadratic formula to find our x. Okay, right. Let's just do that. Let's find our the x coordinates of the points of intersection of the line M and P and the circle with center P. Right. Let's just do that. Now this is our equation. So x is equal to minus b plus or minus the square root of b squared minus 4ac, all this over 2a. Right, and then let's substitute x equal to negative 150, then plus or minus the square root of negative 150 squared minus 4. A is 25, then C is 189. All this over what? Over 2 times 25. Then you put this in the calculator. You can use the calculator here. So you get that x is equal to 9 over 5, or x is equal to 21 over 5. We're getting two answers. Why? Oh, check that if you extend this line here, okay, so there is an x value here also, okay, which is, this is going to be 21 over the x coordinate, not the y, x. So it's 21 over 5. This one is going to be 9 over 5. So this one is not applicable for, so we're going to use this one. So therefore, x is equal to 9 over 5. Right, and then what we do to get our y coordinate of n, we can use the equation of what? The equation of m and p. Do you remember the equation of m and p? It is 3y plus 4x is equal to 12. Yeah, that's the equation of m and p. So where there's x, we put what? We put 9 over 5. So it's going to be 3y plus 4, then 9 over 5 is equal to 12. Right, so it means 3y is equal to 12 minus 36 over 5. 4 times 9 there is 36 over 5. And then you can even use your calculator here. Okay, 3y is equal to 24 over 5. Use your calculator, you must get the same answer. And then divide by 3 on both sides of the equation. So y is equal to 8 over 5. So therefore, this n here is going to be 9, the x coordinate 9 over 5, and then the y coordinate is 8 over 5. Okay, so therefore, the coordinates of n, 9 over 5 to 8 over 5. See that? Okay, right, we haven't answered the question. We want, remember, we want the y-intercept of the tangent common to the circles. We want the y-intercept of this tangent. So let's continue. Now we have the coordinates of what? Of n. We have the coordinates of n. So let's just do the last part. We say the coordinates of n are what? It's what? 9 over 5, then 8 over 5. Okay, right. So now we need to find the gradient of m and p. So the equation of the line m and p is 3y plus 4x is equal to 12. How can you find the gradient of this line? So we have to write this equation in the form y is equal to m x plus c, or you can say f of x is equal to ax plus q. Okay, where m will be the gradient, right? And then c is the y-intercept. Okay, c is the y-intercept. So now let's write that. So we're saying here is going to be 3y is equal to negative 4x plus 12. Then we divide by 3 everything. Y is equal to negative 4 over 3. 3, 12 divided by 3 is 4. So 4. You see that? Okay. So now the gradient of m and p is equal to negative 4 over 3. So therefore, the gradient of the tangent is the negative reciprocal of this. Negative reciprocal of this. So it's going to be is 3 over 4. 3 over 4. So now we have the gradient of the tangent, which is 3 over 4. Remember now, we want the equation of the tangent. So y is equal to mx plus c. So we have our y, which is what? 8 over 5. So 8 over 5 is equal to the gradient, which is 3 over 4. 3 over 4. And then our x is what? 9 over 5 plus c. Okay. So meaning that we have 8 over 5 minus, this is 27 over 20. 3 times 9 is 27. 5 times 4 is 20. So then we bring this side. So it's going to be 8 over 5 minus 27 over 20 is equal to C. Then put that in the calculator. You'll get that 1 over 4 is equal to C. Therefore, the y-intercept of the tangent is 1 over 4. We can say the coordinates is what? Is 0, 1 over 4. Okay, those are the coordinates of the y-intercept. Okay, right. So that's what you're supposed to do then. Now, and then the other method will be to use similarity. Now, if you check here, we can do some construction here. Let's just go straight to that. We've discussed the information, so let's go straight to that. So what I'm going to do, we draw a line which is parallel to the x-axis. Right, you see that? So this line is dividing, let's call this one O, is dividing MP and MO proportionally. If it's going to be parallel like this. This line, let's call it Q. Right, this line QN is dividing MP and MO proportional. Remember, we managed to get the MN were given as 3 units. In question 11A, we managed to get the radius there of what? The circle with center P. And then we said NP is 2. We managed to get that in question 11A. Okay, so now we can use what? Similarity here, because these two triangles, MQN and triangle MOP, are similar. Okay, we're going to do everything there. Okay, right. So that's the approach we're going to use. And then when we get the length of QN, let's say QN is 2 units. What is the x coordinate of n? If QN is 2 units, QN is parallel to the x-axis. And if it's 2 units, it means the x coordinate is going to be 2, isn't it? Right, so we just find the length of QN. That will give us the x coordinate of what? Of n. You see that? Okay, that's the approach. Let's just do that. So we have, let's construct here. You see that? And then we have the 2 triangles. Let's name the 2 triangles. In triangle MOP and triangle MQN. Please try to identify the triangles we're talking about. The bigger triangle, MOP, and the smaller triangle, MQN. Okay, so we can see that these two are equal. Even let's start with M, which is a common what? A common angle for the 2 triangles. For the 2 triangles. Okay, you can highlight them there in your paper. Right, so we have angle M is equal to angle M. Okay, we're starting with what? With the bigger triangle, MOP, and then followed by the smaller triangle. So angle M there, and M is common. Right, and then angle, we start with the angle what? The bigger one, O1. Let's say angle O1 is equal to angle Q1. Right, corresponding angles. You see QN is parallel to OP. We constructed a parallel line there. Right, and then again we can see P1 is equal to N2, corresponding still, but also you can use third angle of triangle. So P1 is equal to N2. Okay, third angle of triangle. Right, so you see that. And then now we can say therefore triangle MOP is what? Is similar to triangle. If you check, M goes with M. O goes with Q. P goes with N. You see that? So triangle MOP is similar to triangle MQN. And then there is in angle. You see that? Okay. Right. And then from here, we can see that MO over MQ is equal to OP over QN. OP over QN is equal to MP over MN. MP over MN. Okay. Right. And then let's check what we're looking for. We're looking for QN. So we have QN there. Do we have OP? OP. We don't have OP. Okay. No, we have OP. What are the coordinates of? We found the coordinates of P here. It was what? It was 3, 0. On question 11, do you remember that? Question 11, this one was 0 for 11A. Question 11A. Okay. So it means OP is what? Is 3 units. We have that OP. And then MP. What is MP? From there up to there. MP is going to be 3 plus 2, isn't it? 3 plus 2, which is 5. We have that. And then MN, we have MN, which is 3 units. We have that. So we just need these 4. Okay. Right. Remember the reason why you wrote this statement, because say that sides in proportion. Okay. So here we can say therefore OP over QN is equal to MP over MN. Okay. Right. Now let's substitute what we have and then solve for QN. So we're substituting now. We have discussed everything. OP is, this is 3, 0 here, coordinates, and then 0, 4 here. Okay. Right. So OP is 3, and then over QN is equal to MP, which is 5, over MN, which is 3. And then we want to get QN, so we can cross multiply here. Remember, when you cross multiply, this and this, this and this. Okay. So whichever way, you can use a different method or different cross multiplication is fine. We're going to get the same answer. So this is 5 times QN is equal to 3 times 3, which is 9. Divide by 5 both sides. QN is equal to 9 over 5. Meaning that this distance here from there up to there is 9 over 5. And then we discussed this, say that this distance will give us the x-coordinate. The x-coordinate of what? The x-coordinate of n. So it means n here we know that is 9 over 5. We just need to find what? To find the y-coordinate. Okay. Right. Now let's find the y-coordinate. We're going back to the equation of the line MNP. So it's going to be 3y plus 4x is equal to 12. And then substitute 9 over 5 there. So 3y plus 4 times 9 over 5 is equal to 12. And then we say 3y is equal to 12 minus 36 over 5. And then 3y is equal to 24 over 5. And then we divide by 3 on both sides. So y is equal to 8 over 5. Okay, see that? Therefore, n is 9 over 5 and 8 over 5 there. Those are the coordinates of n. So this is 8 over 5. See that? Okay, so now let's answer the question. Determine the y-intercept of the tangent common to the circles at n. So same thing here. We have the gradient of m and p. Let's just do the last part there. So we have the gradient of m and p. We just did this in the alternative method. So 9 over 5 here, 8 over 5. So we say the gradient of m and p, we have to write our equation in the form y is equal to mx plus c. So our question was 3y plus 4x is equal to 12. Then 3y is equal to negative 4x plus 12. Then y is equal to negative 4 over 3x plus 4. That meaning that the gradient of m n p is equal to negative 4 over 3. Then the gradient of the tangent is the negative reciprocal of this. So the gradient of tangent is equal to 3 over 4. And then now using the gradient and these coordinates here, y is equal to mx plus c. So it's 8 over 5 is equal to 3 over 4, and then 9 over 5 plus c. Okay. So we have 8 over 5 is equal to 27 over 20 plus c. Right, 8 over 5 minus 27 over 20 is equal to c. So 1 over 4 is equal to c. Therefore, the y-intercept is 1 over 4. We can say the coordinates of the y-intercept will be what? 0, 1 over 4. Okay, so that's what we could have done there in that question. I really hope that you managed to understand. It was a bit long, but yeah, that's how we're supposed to do it. Thank you very much. We're going to meet when you do our last question of the paper, which is question 12.